In this video, let me consider two numericals on parallel resonant circuits. For the parallel resonant circuit shown below, find IO, IL, IC, FO, that is resonant frequency, and dynamic resistance. This is the given circuit. For this circuit, we are supposed to calculate these all parameters. And in second problem, in a two-branch RL, RC parallel resonant circuits, L and C values are given. We are supposed to calculate the resonant frequency by considering these different cases. Let me consider the first example, that is parallel resonant circuit. For the parallel resonant circuit shown below, find these all parameters. So here first let me calculate the resonant frequency, that is F0. So this is tank circuit of parallel resonant circuit. The resonant frequency for tank circuit is given by the formula 1 over 2 pi. We have under root 1 upon LC minus RL square by L square. This is the formula. So in this case, L value is 10 microhenry, C is 100 picofarad, and RL is 10. Let me substitute the values. F0 equal to 1 over 2 pi. We have 1 upon L value is 10 into 10 power minus 6 into C value is 100 picofarad, that is 100 into 10 power minus 12 minus RL square. RL is 10, that is 10 square divided by L. L value is 10 micro, that is 10 into 10 power minus 6 square. Let me solve this. That is F0 equal to 1 over 2 pi under root. We have is 10 power 15 minus 10 power 12. So solving this, we'll get F0 equal to 5.0304 megahertz, that is into 10 power 6 hertz, or F0 equal to 5.034 megahertz. So this is the resonant frequency F0. Now let me calculate the dynamic resistance first. The dynamic resistance is represented as ZD, and it is given by L by CRL. So here given L value is 10 microhenry, that is 10 into 10 power minus 6. Capacitor value is given, that is 100 picofarad. 100 into 10 power minus 12 into RL value is given, that is 10. So let me simplify this. So it gives 10 into 10 power 3 ohm, or I can write it as 10 kilo ohm. So therefore ZD is equal to 10 kilo ohm. So now to find, that is IO can be represented as, IO is total current, which is given by V by R. We know that current is equal to voltage by resistor. So here the resistor is nothing but dynamic impedance. So the supply voltage is here 100 volt. That is 100 volt divided by ZD, or I can write it as 100 divided by 10 kilo, which is nothing but 10 into 10 power minus 3 amp, or I can write it as I0 is equal to 10 milliamp. Now let me calculate IL and IC. So to find IL and IC, we first calculate the quality factor. The quality factor is given by Q0 is equal to 1 over R under root L by C. So let me substitute the values. It is 1 upon 10 under root L value is 10 into 10 power minus 6 divided by C value is 100 into 10 power minus 12. Let me simplify this. It gives 31.62. So now therefore the current through inductor branch and current through capacitor branch are same, that is IL is equal to IC is equal to quality factor into I naught. So here quality factor value is 31.62 into I naught is 10 into 10 power minus 3. Solving this will get 316.227 millihenry. So therefore IL is equal to IC is equal to 316.227 milliamp. Thus we found all parameters. In a two branch RL RC parallel resonant circuit, L is equal to 0.4 Henry and C is 40 microfarad. Now we are supposed to calculate the resonant frequency for these all different cases. So before starting with different cases, so let me draw the two branch parallel circuit. So this is two branch parallel circuit, that is this is RL, this is L, this is C and this is RC. So the parallel resonant frequency expression is given by, we have omega naught is equal to 1 upon square root of LC under root RL square minus L by C divided by RC square minus L by C. This is the formula used to calculate resonant frequency in case of two branch parallel circuit. So here given values are L is equal to 0.4 and C is equal to 40 into 10 power minus 6 farad. So for easy simplification, I will first calculate 1 upon square root of LC, that is L into C can be given as 0.4 into 40 into 10 power minus 6. So calculating this, we'll get it as 16 into 10 power 6. Let me calculate 1 upon square root of LC, that is 1 upon square root of LC will be equal to 1 upon under root, that is 16 into 10 power 6. So it gives the result as 250. So in both we have L by C. Let me calculate L by C. So L is 0.4, C is 40 micro. So solving this will get 10 power 4. So now therefore I can write omega naught is equal to 1 upon square root of LC means 250. We have square root of RL square minus 10 power 4 divided by RC square minus 10 power 4. Call it as equation 1. So now let me consider the different cases. The first case is RL equal to 120 ohm and RC is 80 ohm. That is case 1. RL is equal to 120 ohm and RC is equal to 80 ohm. Let me substitute in this equation so that I can get omega naught is equal to 250. We have RL is 120 square minus 10 power 4 divided by RC is 80 square minus 10 power 4. So let me solve this. I'll get omega naught is equal to 250 under root. We have 120 square minus 10 power 4. It gives the result as 4400 divided by, we have 80 square minus 10 power 4. It gives the result as minus 3600. So here we can see that we have got the minus term inside the under root. It means that there is a presence of J term. So if J term is present, the circuit is said to be not resonant, or resonance is not possible, because in parallel resonant circuit the resonance takes place when imaginary part is 0. Here we will get the imaginary part. Therefore, for this case, that is when we consider RL equal to 120 ohm and RC equal to 80 ohm, the resonance is not possible. That is, resonance is not possible. Now let me consider the case 2. That is, in case 2 we have RL equal to RC equal to 80 ohm. Therefore I can write omega naught is equal to 250 in bracket, that is this formula, 80 square minus 10 power 4 divided by 80 square minus 10 power 4. So here solving this, so this term will get cancelled, will become 1, the square root of 1 is 1, therefore omega naught is equal to 250 radians per second. So this is the resonant frequency, that is omega naught is equal to 250 radians per second. Radians per second. So this is the resonant frequency when we consider RL equal to RC equal to 80 ohm. Now let me consider the third case, where RL is equal to 80 and RC is equal to 0. That is, omega naught is equal to 250 in bracket. We have the formula, that is RL square minus 10 power 4, 80 square minus 10 power 4 divided by, we have 0 minus 10 power 4. So let me solve this. So solving this, we'll get omega naught is equal to 150 radians per second. So this is the resonant frequency when we consider RL equal to 80 and RC equal to 0. Now let me consider the fourth case. So let me write here, that is RL is equal to RC is equal to 100. Therefore I can write omega naught is equal to 250 under root, we have 100 square minus 10 power 4 divided by 100 square minus 10 power 4. Solving this, I will get 50 in bracket, we have here 100 square minus 10 power 4 is 0 divided by 0. So it is 0 by 0 form. So if it is 0 by 0 form, you can say that the result is indeterminate. Here result is indeterminate. Therefore it resonates at all frequencies. Let me consider the fifth case, where RL is equal to RC is equal to 120. In that case, we have omega naught is equal to 250 under root, we have 120 square minus 10 power 4 divided by 120 square minus 10 power 4. So solving this, we'll get omega naught is equal to 250 radians per second. Thus we found the resonant frequency for different cases.